Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arifin bin Sabri. I'm from 1AM1 and I'm studying in Medical MIAT, Malaysia Institute of Aviation Technology. This video is prepared for my physics and aerodynamics lecturer, Puan Azinda binti Abu Bakar, and all of you that see my videos. I love to know that you have learned something from my video and I hope you enjoy it. So let's start with the first topic, that is optic light. As you can see, there's 5 subtopics of optic light that I will share with you what I have learned. First is I want to ask you what you know about the optic light. Okay, optic light is a light wave are a part of a group of electromagnetic wave or radiation that include X-rays, ultraviolet, infrared rays, and radio wave. Light wave have certain properties which are common. These travel through space at the speed of light, 186,005 miles per second or 300,000 km per second. They obey the equation V equals to frequency times lambda. They carry energy from one place to another, and on their observation cause a rise in temperature of the absorbing body. Okay, here you can see the electromagnetic spectrum figure. That you can see long wavelength have low energy and low frequency, while short wavelength have high energy and high frequency. Let's go to light division. Within the light spectrum, there are 6 colors that can be readily identified: red, orange, yellow, green, blue, and violet, with indigo being difficultly to distinguish. As you can see here, the pink flag logo, actually the glass prism, says that Newton was the first person to explain this band of colors known as spectrum using the glass prism. When light passes through, when light passes through from one medium to another, it's reflected. Change the angle. When while light passes through the prism is refracted twice. Right, light refracted at the least, the violet light refracts the most. The separation of the light is manner into the colors of spectrum is called diffraction. Okay, now I show you the color combination. Okay, objects appear colors because their surface will absorb some of the frequencies and reflect others. A red filter, for example, will only low light with the longer wavelength associated with the red color pass through. Red, green, and blue are known as a light primary color as they cannot be created. Secondary color can be created by using 2 primary colors. Reflection. Reflection is the change in direction of rays when it bounces off a boundary. There are 2 laws of reflection. The angle of incident I is equal to the angle of reflection R. The reflected ray lies in the same plane as a incident ray, and the normal at the point incident. This law of reflection applies equally to curved and flat surface. Curved mirror are 2 types, concave and convex. Okay, now here we are at the second subtopic. Okay, here is a difference between concave and convex surface. Convex surface is a surface where the center is shaped out towards the observer. It is in opposite direction to a concave surface. A concave mirror is a surface that is shaped in towards the middle and away from the observer. As you can see here, the point P is known as the pole and the center of the curved mirror. Point C is the center of curvature and is the center of the sphere of which the curved mirror is part. Point F is called the principal focus or focal point as you study in SPM for concave and convex lens or mirror. As you can see the figure below. Okay, now we go to the refraction. A change in direction of light ray occurs when the light move from one medium to another. Example, air into water. This is called refraction. The direction in which they are refracted depends upon when they move into a more dense or less than medium, effectively slow down or speed up. This is what we see every day. We call it refraction. Observation on light refraction. The ray of light is bent towards the normal when it enters an optically denser medium at an angle. The area of light is bent away from the normal as it enters optically less dense medium. Example is moved from glass to air. Should the ray arrange to enter the block along the normal at 90 degrees to the surface is not affected. as you can see, figure here. Alright, now it's light refractive index. Okay, as you can see the formula here, N is called for stand for refractive index. C is velocity of light in vacuum, and V is velocity of light in the medium. So to find refractive index, you must C divided by V. Alright, in vacuum, the light wave travel at 300 km per second, whereas in glass, the velocity falls into 200 km per second. Alright, next we go to Snell's law. The Snell's law says the ratio of the sine of the angle of incidence to the sine of the angle of reaction at the boundary of the two substances is always constant. The constant may be expressed as the refractive index of substance 2 with respect to substance 1. That's for 1 and 2. The relative refractive index of the two media is the ratio of the sine of the angle of incidence to the sine the angle refraction for a ray passing through the media into the other. Alright, for refractive index air, refractive index in water, the coefficient is 1.33, while when you want to find the coefficient of water refractive index in air, 1 is divided by 1.33 and you got 0.75. As you can see, the Snell's law here. Okay, this then is same goes to the convex and concave mirror. Now we go to the next main topic that we call chapter 10, sound. I know everybody loves the music, and there's many types genre of music: rave, rock, slow song, high song, disco, or anything else. But today I will share with you where is the sound, where is the music come from. Alright, we call it as mechanical wave. Alright, from here you can see the energy can travel in two forms of method, by particle or by wave. You can see the figure here. A wave is disturbance of a medium which transports energy through the medium without permanently transporting matter. In a wave, particles of the medium are temporarily displaced and then return to their original position. The two most common forms of mechanical wave are transverse wave and longitudinal wave. Alright, here you can see in a transverse wave, particles of the medium are displaced in a direction perpendicular to the direction of the energy transport. Alright, you can see move like this. The particles do not move along with the wave, but they simply oscillate up and down their equilibrium position as the wave passes. Alright, let's go to the longitudinal. You can see longitudinal move right to left, right to left, right to left. We call it as direction parallel to the energy transport. Alright, water wave. Water wave are example of water that involve combination of both longitudinal and transverse motion. As the wave travels through the water, the particle travels in clockwise circle, the radius of circle decrease and depth of water increase. Observe the particle of the blue color and indeed travels clockwise in direction. You can see the water wave at deep and shallow. Alright. What wave characteristic here about wavelength? Wavelength is the distance between two crests, here and here, or the crest. Calculate the number of wave crests past a point every second. If one crest goes by your every second, then when we see that the frequency is 1 cycle per second or 1 Hz. Amplitude is the height of the wave about the different position. Velocity is the speed of direction that makes wave crest itself is moving. See the figure here. There is a simple relationship between the wavelength frequency and the velocity. If you know any two of them, then you can compute 3 using the formula. Wavelength equals to wave speed divided by frequency. Interference wave and standing wave. Interference or supporting occurs at point 2 or more wavelengths. There are two types of common interference: constructive interference and destructive interference. Constructive interference is just increase in disturbance and a waveform with a greater amplitude, while destructive is the effect is reduce the amplitude of the first wave. Standing wave. The standing wave stationary wave occur at a tightly stretched between 2 points. If this wire are plugged or cause a vibrate, transverse wave travel the end are reflected back. And these waves are each other, they are travel backward and forward along the wire. A stationary or standing wave pattern is formed. For wave height are in phase, the combined amplitude is large, and when out of phase is subsequently small or even zero. Standing wave pattern are characterized by certain fixed point along the medium which undergo no displacement. This point of no displacement called nodes. Meanwhile, midway between every consecutive nodal point are points which undergo maximum displacement. These points are called antinodes. Alright, go to sound. Sound is energy, is produced with an object, vibrates causing the surround in particular vibrate also. Sound travel the air, longitudinal wave. Sound wave are called acoustic wave. A region high pressure as low pressure known as compression and refraction. Region where molecules gathered together close together is known as compression, and they move apart we call refraction. This is the formula. Doppler effect. Doppler effect is a charge change in frequency which occur when the source that is emitting the sound wave is moved. Sound wave in front of the object, they become closer together, giving the appearance of a smaller wavelength and of greater frequency. Wave behind moving object, the opposite occur, giving the appearance of larger wavelength and a lower frequency. Sound intensity determined by the amplitude of the sound wave. The higher the amplitude, the higher the sound. Measured in decibel. Ratio 1 of sound to another, 1 dB. The smallest change in sound intensity the human ear can detect. Frequency, the number of vibration complete per second. Frequency equal to 1 over t, where t is time in second. Unit used in hertz. And higher the sound is the higher the pitch. Sound propagation, transmission, the reception of sound, source, medium, detector, range of human can hear 20 to 2000 Hz. Doppler effect, the apparent rise in the pitch or frequency of a sound. As its sound approaches the hearer and the decrease in pitch as the source of move away. Sound vibration, cause waves which radiate out from their source and speed of sound. Aircraft move less than speed of sound, the sound moves ahead the craft. As you can see, the aircraft is moved less than the speed of the sound. Aircraft flies at the speed of sound with shock wave. Speed of sound, the speed at which the mechanical vibration of sound travel in elastic medium, varies the temperature of an altitude. As you can see the figure here. Alright, now we go to the Mach number. Mach number is the ratio of the speed of the airplane to the speed of the sound in the same atmospheric condition. The formula is Mach number is equal to speed of the aircraft divided by speed of sound. Resonance is the natural frequency of a given object vibrates naturally or without the external force. Two objects have similar frequency. If one vibrates the other, they can move too. And resonance is a destructive force. Alright? Does this? Okay, that's all for me. I hope you enjoy my presentation. I hope I get the likes there because the like is for my carry mark for this SEM 1. I hope all of you enjoy my video and have some new learns about what I have learned. And I love to share what I learned here. And then that's all from me. Thank you again. Assalamualaikum warahmatullahi wabarakatuh.